And then once the witch is actually on the pyre, there are I guess I would say 4 really important options to know about. There are actually a few more than that, but just know about these. Okay, so first off, she can try to survive. And one way she could do that is say, wait, no, I'm pregnant, and say, I'm lactating. And because the people in the witch hunt are obviously pro-life, they can't burn her. So she can be converted into lactate. Completely different from lactating, but it sounds kind of the same. So one option is she can be converted into lactate and then be brought to the liver. Okay? And if somebody was going to be brought to jail, and what might that person call jail? They might call it the slammer. But let's say you were going to be brought to jail and the alternative was that you were going to be burned at the stake. Then you might call jail the liver. Okay? Sorry to the people who've heard that joke before. But, so yeah, if she gets converted into lactate, she'll get brought to the liver. Okay? Same thing with alanine. So one option is you can say, wait, no, I'm pregnant. Can't kill me. I'm with child. Or the other option is she can say, she can yell, Allah 9. Allah 9. Like denying Allah, but in German. And that is also very confusing to the witch hunters, because it seems like she's denying Allah, and they would like that, but they're not quite sure what to do. So in this case, she is also brought to the liver. Okay? But those are temporary solutions, because in the end, both the alanine and the lactate will be converted back into pyruvate. So those are like a medium. You could think of that as a medium-term storage. If you thought of fat as long-term storage, you could think, and you thought of glycogen as really, really short-term storage, you could think of lactate and alanine in the liver kind of as a medium-term storage. There's a lot more detail to that, but for now you could just sort of think of it that way. So anyway, those are 2 options. Third option is they can just burn her with an enzyme called pyruvate dehydrogenase. And that gives off some CO2, kind of like smoke. So the pyre gets dehydrated while they burn her, and the coenzymes for that, there are several mnemonics, but the one that works with this would be tinder lighting, starting fire now.
Say that again.
Tinder lighting.
Lighting.
Yeah.
L-I-G-H-T.
Causing fire now. Let me write that out.
Yeah.
Do y'all need to know that much detail?
Yeah.
Y'all need to? Okay.
All of the details.
Okay. So let's see, that's okay, I can't remember what those are.
Thiamine.
Yeah, lipoic acid.
Yeah. NADH.
Yeah, thiamine, lipoic acid, CoA, FAD, and NAD+. Okay. But if you remember this, you should be able to get that. So those are all the coenzymes needed for pyruvate dehydrogenase. Okay? And if that is the step, if that's the direction that the pathway goes, she gets melted down into acid coal. Okay? So when witches get melted down, when they get burned, the whole purpose of that for the cell is that the witches get melted down into acid coal. Okay? Take note that pyruvate was a 3-carbon molecule, 1 CO2 left, so acetyl-CoA is a 2-carbon molecule, okay? And then this acid coal can be used for many different things. The sort of acidy part can be used in the citric acid cycle. That's how I think of that. It can also be used in fatty acid synthesis. It can also be used in ketogenesis. It can also be used to make cholesterol. Okay, so
Ketogenesis, are we allowed to ask questions?
yes,
Ketogenesis, is that the production of ketones? or-
yes,
So,
precisely.
analog of, say like acetone, but the different.
Yes,
Mhm.
that would be an
Okay.
example.
Super,
Yes.
super, okay.
Yeah. And then there's a fourth thing that can happen, and this is the only option whereby the witch actually escapes and gets to go free as a gypsy. Okay? And this will make more sense once I explain my memory palace for the citric acid cycle. But I'll go over it now just real quick. Pyruvate, so there are 2 enzymes. There's pyruvate decarboxylase.
Carboxylase, one.
Carboxylase. Oh, gosh, here. Yeah,
From
pyruvate
pyruvate
carboxylase.
One.
Yep.
So
And then PEP carboxylase. So I drew these 2 steps out as railroad tracks.
carboxykinase.
Oh yeah, you're right. Yeah. Because it uses a GTP.
Mm-hmm.
Yep. Whereas this one is a carboxylase because it uses an ATP. Yeah, thank you. Anyway, I think about them as boxcars. Like the witch is on the pyre, and there's a train track nearby, and if she jumps on that train track, she jumps the train, then she can avoid getting burned, get to oxaloacetate, which I think about just as an ox, which guess what, will have 2 horns, like the bad shoulder angel. So anyway, she can impersonate the ox, which I'll talk more about in the citric acid cycle. And then she jumps on another train going the opposite direction, gets a fake guard, a GTP, so it's not quite like those ATP guards, it's a fake guard, a GTP who's only pretending to arrest her, and then all those steps go backwards up to glucose. And that's the process of gluconeogenesis, okay? Okay, so any questions so far?
This is a stupid question, but are these in equal, I mean, you got the arrows going both ways, I mean,
Mhm.
these are in equilibria that are determined by
Yep.
environment.
Yeah, so wherever I have 2 arrows, that means there are 2 separate enzymes that both only go in one direction. So this is glucokinase or hexokinase. That's one enzyme that only goes in one direction. Same thing here. There are 2 separate enzymes that go each way. Whenever I have an arrow with a light green and a dark green, it's one enzyme that can go both directions depending on the equilibrium. And then if there's just a green arrow going one way, that means that there's only one enzyme and it only goes in one direction. So there's no creating any other sugars. There's only creating new glucose. There's only gluconeogenesis.
Another stupid question, but is all of this happening in the cytoplasm, or is part of this mitochondrial? or
Different
what?
places.
Okay.
Yeah, and that's a good question, and y'all do need to know that. So glycolysis takes place in the cytoplasm, and the citric acid cycle takes place in the mitochondria, and there'll be some more detail on that later with the transport. So let's see, I have, did I draw some of the transporters somewhere? Okay, yeah. So over here, pyruvate can get transported from the cytosol into the, across the outer and inner membranes, and then the citric acid cycle takes place in the inside of the mitochondria. Okay? Okay, any questions so far? Any more questions? Okay, okay, pause, stop the video for now.